Today let's see how to do exercise 1.3. Prove that root 5 is irrational. For finding the solution for this one, we are using theorem 1.4. Root 2 is irrational. The same steps we are following for proving root 5 is irrational. For that we are using the theorem 1.3 also. Theorem 1.3 states that let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. I will show you this one with one example. This theorem also you are using in the proof. So here I took p as 2. P is a prime number, 2 is a prime, and a is 4. Then p divides a square means 2 divides a square means 4 square, that is 16. We know that 2 divides 16, where a is any positive integer. 4 is a positive integer. Then theorem says that if p divides a square, that means 4 square, then p divides a also. P divides 4 also. So keep this in the mind. We are using this theorem for proving root 5 is irrational. For that, we are using the contradiction method. So in this exercise, we are using this proof by contradiction method to prove all this. That means here in theorem 4, it is given that root 2 is irrational. We have to prove. For that, first we assume to the contrary that root 2 is rational. So same like that, here also we are assuming that root 5 is a rational number, and we will get the conclusion that our assumption was wrong. Therefore, root 5 is irrational. So we are following the same steps in this theorem to prove root 5 is irrational. Before that, this one you already learned in the previous class. Rational numbers can be expressed in the form p by q, where q not equal to 0. P and q are integers. So any rational number we can write it in the form p by q. Keep this also in your mind. So we can write like this. We are assuming that this is the contrary method, contradiction methods to the contrary, that root 5 is rational. We are assuming it in the opposite way, that root 5 is rational. We have to prove that it is irrational. Now, as I show you before, we can write this root 5 equals p by q. Any rational number can be written in the form p by q, where q not equal to 0 and p and q are integers. P and q are integers. We can write the rational number. We can express the rational number in the form p by q. This you already studied in grade 9. Now we write root 5 as p by q because we assume that root 5 is a rational number, and rational number can be represented in the form p by q. I will show you one example. If p equals 4 and q equals 10, p and q are some integer. If we cancel it, 2 2s are 4 and 2 5s are 10. 2 by 5. Now we cannot cancel it anymore, and there is no common term between these two. So 2 by 5 is the simplest form. So if we are writing it in the simplest form, it will come a by b, where a and b are co-prime. Co-prime means they have no common term. Hence, we can write root 5 equals a by b, where a and b are co-prime. Now we have to cross multiply this. So this b will go to the left side. Root 5b equals a. Now we have to square both sides. Squaring both sides. Squaring both sides, we will get root 5b square equals a square. Root 5 square is root 5 into root 5, which is equal to 5. 5b square equals a square. Mark it as equation number 1. So here 5b square equals a square. A and b are some integers, and this is the product of 5 into b square. So this is a product of 5, which this and this are equal. This term right hand side and left hand side are equal. That means this one is also, a square is also a multiple of 5. Therefore, we can say that this means that a square can be written as the multiple of 5, because LHS equals RHS, both sides are equal, and the left side is a multiple of 5. Therefore, right hand side is also a multiple of 5. This means that a square can be written as the multiple of 5. Therefore, what we can say, 5 divides a square. Then we have to use theorem 1.3. Then by 1.3 what it says, if a prime number divides a square, then it divides a also. So here 5 divides a square, then 5 divides a also. 5 divides a also by theorem 1.3. Next we have to assume that a equals 5c, because in the question it is root 5. We have to prove root 5 is irrational, that is 5. That is why I use here 5. If it is root 2, you have to substitute the value as 2c, root 3 then 3c, like that. Okay. Now we have to substitute the value of a in equation 1. Substituting in equation 1, we get 5b square equals a equals 5c, then 5c square. That is 5b square equals 5 square is 25c square. Now we can divide it with 5. Dividing by 5, we will get b square equals 5c square. See, now this is equation number 2. Now look at this. So b square we can write as the multiple of 5. 5 b square is the b square we can express as a multiple of 5, which means that 5 divides b square. If 5 divides b square, then 5 divides b also by theorem 1.3. This means that 5 divides b square, and so 5 divides b using theorem 1.3 with p equals 5. So in our proof, we prove that 5 divides a and 5 divides b. What we can understand from this is a and b have common factor 5, which is a contradiction, because we wrote here a and b are co-prime. That means co-prime means no common term, but we prove that a and b has a common term 5, which is a contradiction. So we can conclude that our assumption was wrong and root 5 is irrational. You have to conclude like this: 5 divides a and b, which means a and b have common factor 5, which is a contradiction, because we wrote there a and b are co-prime. They don't have any common factor. That is the contradiction. This contradiction happens because our assumption was wrong. What we assume that root 5 is irrational. Root 5 is rational. That was wrong. Therefore, we can write root 5 is irrational. Question number 2. Prove that 3 plus 2 root 5 is irrational. This also we are doing in the same method of contradiction. We assume that 3 plus 2 root 5 is rational, and then we will prove that our assumption was wrong. Therefore, 3 plus 2 root 5 is irrational. Let's see how to do this. Now here we have to assume to the contrary that 3 plus 2 root 5 is rational, and we know that rational number can be expressed in the form p by q, and when we simplify p by q, we can write it as a by b, where b not equal to 0, and a and b are co-prime. What we did in the last question, same like that. I am avoiding that p by q step, and writing a by b. This is the simplest form, and a and b are co-prime. That means they don't have any common factor. A and b have no common factor. Now we have to make this term. That means the root 5, the term with root 5 alone. So let it be in the left side, and we can take this 3 to the right side. A by b, this is plus 3. So when it goes to the right side, this will become minus 3. That is, we can write it as 3 by 1. 3 by 1 is same as 3. Now here a by b minus 3 by 1. So we have to take the LCM of it. LCM is b. LCM is b. So how we can write this? 2 root 5 equals a by b. We can write a, and 3 by 1 how we can change? Into b into b. That is 3b by b. A minus 3b by b. Like this it will come. Now we have to make this root 5 alone here. So take this 2 to this side, to the right side. Therefore root 5 equals a minus 3b by b by 2. 2 by 1. Like this it will come. Now if we cross multiply, how it will come? A minus 3b by b into 1 by 2, which is equal to a minus 3b by 2b. So we get root 5 equals a minus 3b by 2b. Here a and b are integers. So here integer minus 3b means b is also an integer, and 3 multiplied by an integer, we will get one integer only. So integer minus integer, we get an answer a integer. And 2b, b is an integer. 2 multiplied by an integer, then also we will get that answer an integer. So integer divided by an integer, which is also an integer. Therefore an integer we can write in the form p by q. This come in the form p by q, where a minus 3b by 2b is in the form p by q. Hence a minus 3b by 2b is a rational number. We know that a rational number, we can express a rational number in the form p by q, but here root 5 is irrational. We already learned that the numbers root 2, root 3, root 5, etc. are irrational because they don't have no perfect square. These numbers not have perfect square, so these numbers are irrational. So the contradiction occurs. Therefore here the RHS is a rational number. Therefore root 5 is also a rational number because LHS and RHS same, equals. But we know that this root 5 is irrational. Therefore we can conclude that our assumption was wrong and 3 plus 2 root 5 is irrational. So here a minus 3b by 2b is in the form of p by q. Hence a minus 3b by 2b is a rational number. Then LHS is also a rational number. Both are equal. That is root 5 is also a rational number. But we know that root 5 is irrational number because it has no perfect square. Therefore this contradiction happens because our assumption was wrong. Therefore 3 plus 2 root 5 is irrational. Third one, 1 by root 2. So this one also same like the above examples. Let us assume that 1 by root 2 is rational, contrary. Then 1 by root 2 equals a by b. We are writing the rational number in the form a by b, where b not equal to 0. A and b are co-prime. Therefore we can cross multiply this. Then we will get 1 into b. 1 into b equals a into root 2. Now we have to make root 2 in one side. Therefore 1 into b, a will go to this side. Therefore by a equals root 2. We get b by a equals root 2. So a and b are integers. Integer by integer we get another integer only. So it is in the form of p by q. P by q, we know that p by q is a rational number. We can express P by Q as a rational number. Therefore, this side is a rational number means this one is also, the right hand side is also rational. But we know that root 2 is irrational. We already proved in the theorem 1.4, and also we know that root 2 is irrational because it doesn't have a perfect square. Therefore, contradiction happens. Here this side rational and this side irrational. Contradiction happens. Therefore, we can say that our assumption is wrong. That is 1 by root 2 is irrational. B by A equals root 2. A and B are integers. So, it is in the form P by Q. Therefore, B by A is rational. Therefore, if left hand side is rational, then right hand side is also rational because equal sign is here. Therefore, root 2 is also rational. But we know that root 2 is irrational. We already learned that root 2 is irrational. Root 2, these numbers does not have a perfect square, and in theorem 1.4 we proved that root 2 is irrational. This contradiction happens because our assumption was wrong. Therefore, 1 by root 2 is irrational. Next one, 7 root 5. Same like the above one. Let us assume to the contrary, 7 root 5 is rational. Then 7 root 5 we can write it as a rational number A by B. 7 root 5 equals A by B, where B not equal to 0. A and B are co-primes. Now we have to keep the root 5 here in the left side and take 7 to the right side because we want to keep the number with root on one side. A by B by 7. It will come like this, 7 by 1. Then when we cross multiply, it will come A by B into 1 by 7, which is equal to A by 7B. Therefore, we get root 5 equals A by 7B. Here A is some integer and B is some integer. 7 into 1 integer, we will get integer. So this is in the form integer by integer. So we can write it as root 5 equals P by Q. It is in the form of a rational numbers. Therefore, A by 7B is in the form of a rational number. That means A by 7B is a rational number, then root 5 is also a rational number. Both are equal. But we know that root 5 is irrational because it has no perfect square. Therefore, our assumption is wrong. Contradiction come. Left hand side is irrational and right hand side is rational. Contradiction come. Therefore, our assumption is wrong and 7 root 5 is irrational. Hence, we can write like this. Therefore, A by 7B is a rational number. Therefore, left hand side root 5 is also a rational number. But we know that root 5 is irrational. Hence, our assumption is wrong and 7 root 5 is irrational. The last one, 6 plus root 2. Here also, let us assume to the contrary that 6 plus root 2 is rational. First, we assume it is a rational number. So, the rational number can be expressed in the form P by Q. When we simplify it, we can write it as A by B, where B not equal to 0. A and B are co-prime. Co-prime means they don't have any common factor. This is the simplest form. So, I am avoiding the step P by Q. And A and B are some integers. Now we have to keep root 2 in the left side and take 6 to the other side. A by B, here plus 6. So when it goes to the right side, this is minus 6. Now we have to take the LCM and solve it. LCM, here LCM is B. Therefore, this will come like this, B, and here A, and 6 by 1, that means 6 into B, which is equal to 6B by B minus 6B by B. Therefore, root 2 equals A minus 6B by B. So, we get root 2 equals A minus 6B by B. A and B are integers. Integer minus 6 into some integer means one integer only. Integer minus integer, we get another integer. And integer divided by integer also we will get integer as the answer. That means a minus 6b by b is a rational number. Therefore, if our right hand side is a rational number, then the left hand side is also rational number. But we know that root 2 is irrational. This happens because our assumption was wrong. Therefore, 6 plus root 2 is irrational. Same like the above questions. Therefore, we can write like this: a minus 6b by b equals p by q as a rational number. A minus 6b by b is a rational number. Therefore, root 2 is also, left hand side, root 2 is also a rational number. But we know that root 2 is irrational. This contradiction happens because our assumption was wrong. Therefore, 6 plus root 2 is irrational.